This is Geeks for Geeks problem of the day. A medium level problem: water the plants. The problem states a gallery with plants is divided into n parts numbered 0, 1, 2, 3 till n minus 1. There are provisions for attaching water sprinklers in each division. A sprinkler with range x at division I can water all divisions from I minus x to I plus x. Given an array gallery consisting of n integers, gallery I is the range of the sprinkler at partition I. Okay, a power of -1 indicates no sprinkler attached. Return the minimum number of sprinklers that need to be turned on to water the entire gallery. If there is no possible way to water the full length using the given sprinklers, print -1. So let's look at the test case. In this test case, n is equal to 6 and we are given an array of 6 elements. As we already read in the problem statement, if it is given -1, that means there is no sprinkler. Right, if it is 2, we can say that this sprinkler at index 1 will water from index -1. Okay, we can say from index 0 because -1 is not there till index 3. Right, 1 plus 2 till index 3. It will water the sprinkler present at index 1. Similarly, sprinkler present at index 2 will water from 0 till 4. At index 3 will not is not there. Sprinkler is not there at index 3. The sprinkler at 4 will water itself only. Similarly, at sprinkler at index 5. So we can say that sprinkler present at index 2 can water from 0 till 4 index, and the sprinkler present at 5th index can water itself. So we need 2 sprinklers to water the entire gallery. In example 2, it is saying that this 4 we can say can water from 0 till index 6. At index 7 there is no sprinkler present and index 8 will water itself. So at index 7 there is no sprinkler, and by no mean we can water this index, this plant. So the answer is -1. Similarly, from the third example, right? So we already got the idea from the problem that there will be intervals at each index. The element can water from index as well as the last index. So we can figure out these intervals via each sprinkler. We can figure out these intervals. Then we have to combine those intervals. Minimum number of intervals we can take so that the entire range is covered. In basic means, in programming terms, we can see this, and this should be the algorithm. First we need to figure out the intervals from the array, and then we need to pick minimum number of intervals such that the whole range is fulfilled. If there is no mean the range is fulfilling, that means there is no possible way. So the outcome should be -1. So this is exactly what I have done here. I have taken an vector of pairs called intervals, and via this for loop I am fulfilling this interval array. I am populating this interval array, and I have put a condition that if the gallery is -1, there is no sprinkler present, so we will not include it in the intervals vector. Right, so here is the starting index and the ending index. I have put a min-max condition to accommodate the first index as well as the last index, so the interval do not go out of the bound. Right, we got the intervals array. Then to pick the minimum, to do that I am sorting it. Because of sorting I will get them in order of first the starting position, then the ending position, so I can easily get the minimum number. And on top of it, I have used dynamic programming. We can take an example. For example, this example only. What will be the intervals? Interval will be, let's skip -1. For this element 2, interval is 0 till 3. Next interval will be 0 till 4. Next interval, we skip this -1. Next interval is 4, 4. Next is 5, 5. Yes. Now if we sort them, what we got? These are in sorted order only. Okay. After sorting, if we go pair by pair, and if first we make a DP array, the index is till 5. Right, first we populate with -1. This DP array, at each index it is -1. It is telling that there is no sprinkler present, that this index is not covered. If there is another number, for example 0, 1, that means one sprinkler is used to water this. Otherwise 2 sprinkler are used to water this range, to water this index. What does that mean? Okay, if at index 1 there is 2, that means 2 sprinklers are used to water till this range. That means 0 and 1 index are watered by 2 sprinklers. So for that thing I have used this DP array. If we will go from this 0 to 3, this is the first interval, we can populate this with 1. From 0 to 3, 1 sprinkler is used. Right, from 0 to 4 we can say, till 4 we can say we can use just 1 sprinkler. Yes, from 4 to 4. First, if we need to include this 4, 4, what we see that till 3 how many sprinklers are used? We can say that till 3 1 sprinkler is used. Right, from 4 I can choose minimum or 1 plus 1. So the minimum is 1 only, at this position 1 is there. Right, from 5th we can say how much is 4. 4 at 4 index how much sprinklers are required? We can say 1 sprinkler is required from the DP array. So we are adding just 1 on it. So at 5 we will require 2 sprinklers. So if we take this 0 to 4 interval and this 5th to 5th interval, we will cover the entire range. So this is how the DP array will work. And of course we have written the -1 condition alongside. If the base is -1, we will just return. And this means that if we are checking this interval but at 4 there is -1, that means 4 is not covered. We already know that as this is in sorted order, intervals are in sorted order, 4 will not be covered later. So that means we will never be able to cover 4. This is a breaking case. We can return -1 here. So at the end, if we will check if any index is negative, right, if any index is negative, we will return that there is no possible way to do it. Otherwise we will return the last element of the DP array as our answer. This solution got submitted. Okay, thank you.